Hello everyone, my name is Kugan, son of Deva, just 26 years old. I am studying in Shalam Learning Center, taking course Bachelor in Project in Facility Management, simply called BPFM, and degree in 4th year. And the reason for I am doing this video for my building strategy subject. And this assignment video presentation, my point is understanding of building information modeling and smart build environment and how the contribution and challenge facing during post construction. First thing I want to explain is introduction of BIM. Building information modeling, shortly we call BIM, provide architectural 3D visualization and a standardized way to share and exchange building information. Recently, there has been an increasing interest in using BIM, not only for design and construction, but also the post-construction management of the build facility. With the emergence of smart build environment (SBE) technology, which embed more spaces with smart objects to enhance the building efficiency, security and comfort of its occupants, there is a need to understand and address the challenge BIM faces in the design, construction and management of the future smart buildings. What is BIM? Building Information Modeling (BIM) is a process that begins with the creation of an intelligent 3D models and enable document management, coordination and simulation during the entire life cycle of a project. BIM is an acronym for Building Information Modeling. It is a highly collaborative process that allows multiple stakeholders and AEC. AEC is architecture, engineering and construction professionals to collaborate on the planning, design and construction of a building within one 3D model. It can also span into the operation and management of buildings using data that owner have access to. This data allows owners and stakeholders to make decisions based on pertinent information derived from the model even after the building is constructed. What is BIM used for? BIM is used to design and document building and infrastructure designs. Every detail of a building is modeled in BIM. The model can be used for analysis to explore design options and to create visualization that help stakeholders understand what the building will look like before it's built. The model is then used to generate the design documentation for construction. How can BIM help you? BIM brings together all of the information about every component of a building in one place. BIM makes it possible for anyone to access the information for any purpose. Example, integrate different aspects of the design more efficiently. In this way, the risk of mistakes or discrepancies in reduce and abortive cost minimized. BIM data can be used to illustrate the entire building life cycle from cradle to cradle, from inspection and design to demolition and material reuse. Spaces, system, products and sequence can be shown in relative scale to each other and in turn relative to the entire project. And by signaling conflict detection, BIM prevent error creeping in at the various stages of development and construction. What is the process of BIM? The process of BIM supports the creation of intelligent data that can be used throughout the life cycles of a building of infrastructure project. There are four types of process in BIM. First one is plan. Plan is the inform how we inform the project planning by combining reality capture and real world data to generate context model of the existing build and natural environment. Okay, second process is design. During this phase, conceptual design analysis, the detailing and documentation are performed. The pre-construction process begins using beam data to inform scheduling and logistics. Third one is build. During this phase, fabrication begins using beam specification. Project construction logistics are shared with trades and contractor to ensure optimum timing and efficiency. The last process is operate. Beam data carries over to operation and maintenance of finished assets. Beam data can be used down the road for cost effective renovation or efficient deconstruction too. Okay, the last one is how beam is used in industry. The first one is architecture, and second one is civil, and the third one is construction. Okay, in the industry of architecture, okay, make better design decision, improve building performance and collaborative more effectually throughout the project life cycle. Okay, in civil industry, okay, use intelligent connected workflow to help improve predictably productivity and profitably. The last one is how beam used in construction. Okay, digitize your construction site and connect project information from design through construction and handover. Okay, SBE is smart build environment as a build environment that embed with smart object such as sensor and actuator with computing and communication capabilities, making the environment sufficiently smart to interact intelligently with and support their human user in their day-to-day activities. In addition, smart buildings not only improve personal safety, comfort and productivity, but also offer better support in terms of operation and maintenance of the building. SBE design and management focus on two aspects, namely sensing and service. Service refer to day-to-day life which affect the real world by changing the user environmental factor including air conditioning and lighting. The sensor-based model is applied to the design of smart spaces. SBE design and post-construction management also support BIM application by analyzing, visualizing, monitoring, checking maintainability, identifying component and updating digital assets. For example, Autodesk integrated BIM with sensor and meter to provide 3D visualization of building performance and life cycle operation. Another crucial aspect in facilities management is the management of energy. In SBEs, energy management can be linked through the smart object including temperature, occupancy and ambient light sensors. Estimates of the building's every energy requirements can be analyzed through the monitoring of the energy usage pattern of the building. In this manner, the facility manager can observe equipment's comfort level by monitoring the building energy efficiency. For example, smart meters and distribute energy resources are types of smart object embedded in beam design of SBE. Recent rapid advance in information and communication technologies (ICT) have led to their pervasive use across industry sectors including building construction. An upcoming and important aspect of ICT use that we anticipate take a stage is the construction and management of emerging smart built environment. Here, smart built environment referred to a built environment that has been embedded with smart objects such as a sensor and actuator. Smart building, the human users refer not only to the building occupants but also to the building owner manager. The former are typically concerned with how a smart building could improve personal safety, comfort and productivity, while the latter are more concerned with how a smart building could better support the operation and management of the building. In addition, as a building are a major source of energy consumption, accounting for 40% of primary energy consumption in most countries. SBE will be expected to harness its new technological capabilities to achieve an unprecedented level of energy efficiency. Therefore, construction SBEs can have a set of requirements and procedures not defined or typically considered in traditional construction settings. Although there has been research conducted on various aspects of SBEs, very little attention has been focused on the role and application of BEAM in the pre and post construction process of SBEs. SBE can utilize the building knowledge of BEAM for planning the layout of sensor, tags, actuator and meters. The performance of smart objects can be verified against known constraints and their layouts optimized for the best functional performance. Okay, the third thing is I want to explain about how BEAM can contribute to the development of SBEs during the post-construction management of a facility. BEAM is actually a process for creating and managing all of the information about a project, leading to an output known as a building information model, which contains digital description for every aspect of the physical project. While BEAM is mostly associated with design and pre-construction is explicitly from the SBE designer or architect during the building design phase. In the post-construction facility management phase, the building manager can apply the information in this BEAM file to perform day-to-day building management, including energy management. To pass the BEAM file and read the profile information, there are two possible options for the design of this research. The first is to extend Revit using a native software development kit SDK to perform the energy management task. The second is to develop a standalone BEAM tool as a separate energy management engine. After much contemplation, we decided to go with the second option, as we believe that building managers will be more familiar with using a building management system BMS for their everyday work than with Revit, which is intended as a computer aided design CAD tool for building designer and architect. Therefore, we opted for the second option, and a standalone BEAM tool for energy management has been developed. We developed the tool using the Unstable Building Information Modeling Toolkit, which provide IFC, parsing and 3D presentation utilities. As different smart objects may have different data input-output interface, the properties parameter specified in our BEAM design in the previous section provide a convenient way for the BEAM tool to handle such a low-level operation. An adapter layer is designed in the research to process the request from BEAM software, which passes the IFC file and demand data exchange for the smart objects. The mapping and parsing operation is illustrated, the software architecture for our developed BEAM tool. Real-time data from the DER, smart meters and sensor are collected and stored in a database. Instead of the real monitoring data from a living room sensor displayed to the user. Example, homeowner or building manager. with real-time data from the smart object, energy management and analysis in BIM software are facilitated and achieved. Real-time generation data of on-site DER shows the current energy production capacities and indicate how many load can be supplied of the power grid. Weather, temperature, building and equipment data from sensor form a view of the present and future energy generation consumption. The pricing information from the smart meter allows the building to perform demand response action in coordination with the power grid. Demonstrate the energy management functionality through a simulation of demand shifting. When the real-time pricing information from the smart meter reach a user-defined thresholds, the software triggers the demand shift process and transmit control command to the energy consuming appliance. As future work, we are working towards an advanced BIM-based building management platform for smart building to host smart grid service and application such as virtual power plant and demand response. Designing smart build environment with BIM. As discussed in the previous section, BIM has the potential to support the entire life cycle of the SBE. Therefore, we started by investigating how existing BIM platform can be further developed to the better support the design of SBE. To date, the most popular BIM software instead Revit suite from Autodesk and Architect and Graphisoft. In this work, we have conducted our SBE design in BIM with Revit, but similar work can be conducted as well in Archicad. Embedding smart object in BIM. The intention is to profile smart objects with Revit during the SBE. Family property parameters are designed to be a mapping from IFC text to the device software programming interface, which can be a middleware or another BIM software. Identification and surface mapping. Finally, to map a smart object from BIM to an individual real world device, the mark tag in BIM is used. The BIM software which pairs the produced BIM file reads the mark tag for the smart object and determine additional runtime information. Example, the internet protocol IP address of the device from a database. This tag is also used to map a smart object to a service descriptor file, which will be detailed in the next section. Design verification framework for SBE. Recall the SBE service to enhance the building's efficiency and security and comfort of its human occupants by being aware of the state of the environment and performing autonomous intelligent actions. Such actions performed by the SBE can be viewed as providing a type of service to the building owner or occupants. In literature, these services are also referred to as a real-world service (RWS). Designing a set of adaptive RWS with various smart objects could become an integral part of future SBE design. During the design phase of SBE, uncertainties may arise that could affect the service integrity and performance. Okay, the fourth one I want to discuss about challenges in integration building information modeling into smart build environment SPE. In the post construction stages of a project, BIM can be extremely vital. The data rich graphical model can be utilized to identify any shortcoming before first breaking ground. The primary advantage of designing an SBE building with BIM lies in the fact that a data-rich BIM model can be used to plan the layout and placement of the sensor, actuator, tags and meters inside the SBE building. The performance of the SME building can be verified against the known parameters, and the layout and location can be optimized for the best functional performance. Incorporating BIM and SPE building can be the answer to the challenge of asset tracking maintenance during the post-construction phases. A BIM model can store the physical information of smart objects, their installed location. These data can be visualized in 3D. It is time to embrace the fact that the building we work, live in shape us. A better building always influences how happy and productive the inhabitants are. Smart buildings are the future of the construction industry. Smart Built Environment SBE technology, which embeds more spaces with smart objects to enhance the building efficiency, security and comfort of its occupants. There is a need to understand and address the challenges BIM faces in the design, construction and management of the future smart buildings. How BIM can contribute to the development of SBE. Since BIM is designed to host information of the building throughout its life cycle, our investigation is cover phases from architecture, design to facility management. Firstly, we extended BIM for the design phase to provide material, device profiling and the information exchange interface for various smart objects. Next, propose the 3-layer verification framework to assist BIM users in identifying possible defects in their SBE design. For the post-construction phase, we have designed a facility management tool to provide advanced energy management of smart grid connect SBE, where smart objects as well as distributed energy resources are deployed. Therefore, investigate how building information modeling can contribute to the pre-construction design and post-construction management phases of smart built environment. The rest of the organized as follow. We review related works. We introduce the general challenges and the opportunity for building information modeling in smart built environment. Building information modeling is first extended in the building design phase to provide material, device profiling and information exchange interface for sensor, smart meters. A facility management tools is developed to provide advanced energy management functions based on building information modeling produced. Okay, now I want to talk about general challenges. A number of questions arise when considering the life cycle of a smart built environment. First is how the smart objects are embedded in the environment. From the aspect of sensor, the physical location and the surrounding setting significantly affect their ability to carry out specific tasks. Example, ambient light or occupancy sensing. From the aspect of the information network, whether a wireless sensor network WSN or wire Ethernet is deployed, it would be designed to offer the smart object an excellent level of communication. Second is how the smart objects interact with the environment. The smart objects are situated in the specific surrounding to carry out their task and often require the input of space data such as building floor plans. Furthermore, in carrying their task, the confluence of the action by different smart objects may involve affecting a common set of environment factors, the impact of which should be studied and understood within a spatial context. Last but not least, when conducting a building performance analysis, such as an energy efficiency analysis of the SBE, not only the information from sensor meter is vital, but the building architectural geometry data are also indispensable. Third is the maintenance of the SAS. Third is the maintenance of such smart objects in a building post-construction phase. In building management, it is common for facility manager to complain about either incomplete or inaccurate documentation. To maintain a smart built environment that is more complicated than traditional structures, more building design and construction data will need to be documented and conveyed to the facility managers. In the event that the company that designed and constructed the building is no longer in business, building management can continue to function properly provided that the documented information is both comprehensive and reliable. Challenge 1. The first challenge is the physical location where smart objects such as sensors are embedded can greatly affect their performance and ability to carry out certain tasks. For example, the location of light detecting sensor can greatly affect the ambient light or occupancy in sense. Apart from this, the wireless network of the Ethernet cable through which these smart objects communicate should be designed to enable perfect communication between them. The second challenge is the way these smart objects embedded in SPE interact with their environment is very crucial. These objects can really function solely on the data they collect from their immediate surrounding, rather they need to be fed the space data such as floor plans of the building too. In the case of conducting a performance analysis or energy analysis of the SB building, along with the information from the sensor, meters, data on building architecture and geometry are also needed. The third challenge is maintaining the smart objects in the building and properly documenting the data from an SBE building is not a work on the beach. In an SBE building, the data will be more complicated than the traditional structures. Digital data storage and its impact on the data recapture. The loss of data in traditional paper based on the process is another challenge issue. Beam collaborative environment mitigated this risk by storing all information digitally and making the data easy readable to all participants. Thus, while a traditional process failed in recapturing all information, Beam stores the data accurately during the world building lifecycle. Okay, from this assignment, I want to conclude that traditional development process in building project is inefficient and face many challenges. The future of building projects lies in the use of technology, and BEAM is expected to build this. The introduction of BEAM into life cycle of building projects require fundamental changes in traditional project development process. Most importantly, BEAM aims to focus the bulk of workload in early design phase when cost of any change is lower and use the CE concept to modify sequential waterfall model into an integrated design model. In general, BEAM is able to revolutionize traditional development process in order to have more time and cost effective process during building life cycle. BEAM is not just a temporary trend, but it can revolutionize the current process of building development. This research finding indicate a need for more detailed understanding of BEAM impact on business process of all disciplines within the industry during the project life.